Some planets have skies that rain molten iron and surfaces of solid diamond. This is a tour of 25 exoplanets with conditions more extreme than hell itself. By the end, you will understand how these alien worlds reshape our most fundamental ideas about reality in the cosmos. What does a planet look like as it evaporates into space? And how can a world be darker than coal yet hotter than lava? We are about to descend into a universe where the rules of nature are rewritten by fire, pressure, and chaos. What do you think it means for a place to be truly alien? We cannot see these planets directly, not with any telescope we currently possess. The star they orbit outshines them by a factor of billions, a single brilliant street lamp drowning out the faint glow of a firefly circling it. So how do we know they are there at all? Astronomers have become cosmic detectives, reading subtle clues in the light of distant suns. The most prolific technique is called the transit method. Imagine watching a distant porch light from miles away. If a tiny moth passes directly in front of that light, the brightness dips just for a moment. On a cosmic scale, that moth is a planet, and the porch light is its star. By measuring those precise, repeating dips in starlight, we can calculate the planet's size and the length of its year. Another powerful method listens for a star's wobble. A planet's gravity doesn't just keep it in orbit, it also tugs on its star, causing it to shift back and forth ever so slightly. This motion imprints a telltale signature on the star's light, allowing us to estimate the planet's mass. Missions like Kepler and TESS have turned these techniques into an industrial process, staring at hundreds of thousands of stars for years, waiting for those critical flickers. This is not speculation. The hellscapes we are about to explore are built on these meticulous measurements, on data points of light collected across the void. Knowing how we found them makes what we found not just strange, but undeniably, breathtakingly real. Our journey begins with a world so close to its star that its very surface is boiling away into space. Hell is a story we tell, a metaphor for ultimate suffering. But the cosmos deals in measurable extremes, in data points of physical fury. To call a planet more extreme than hell, we need a scientific benchmark, a set of parameters that go far beyond just being hot. Our first criterion is temperature so intense it does not just melt rock, but vaporizes it into a thin metallic haze. Next, atmospheric pressure, the sheer weight of an alien sky, must be capable of crushing a substance as hard as diamond into a puddle. We must consider runaway greenhouse effects, where a planet's own atmosphere turns into a furnace it can never escape. There is the strange fate of tidal locking, where one hemisphere faces eternal, blistering daylight and the other is plunged into permanent frozen night. And finally, we have atmospheres not of air, but of pure poison, caustic chemicals that would dissolve a spacecraft before it ever touched the ground. Ancient myths spoke of fiery pits, frozen wastes, and rivers of acid. These exoplanets present something far more compelling. They are not metaphors. They are the physical, verifiable realities that make those ancient stories seem almost quaint. With this framework in place, we have a true measure of cosmic ferocity. Our descent can now begin with a world that is quite literally disintegrating before our eyes. Kepler 10b is a world of fire without end. Orbiting its star in a blistering 20 hours, this planet is so close that its entire sunward face is a single, roiling ocean of molten rock. Surface temperatures soar beyond 2,500 degrees Fahrenheit, hot enough to liquefy iron and vaporize granite. Under a star that appears 3 times larger than our own sun, fixed permanently in a black, airless sky, there are no mountains, no valleys, only a churning magma sea where continents of slightly cooler, solid rock might drift like scum on a cauldron. This is the consequence of tidal locking, where the star's immense gravity has halted the planet's rotation, presenting one face to eternal day and the other to an endless night. While the day side is a vision of pure stellar fury, the night side presents a different question. Could any part of this world offer respite? The answer is a chilling no. Without an atmosphere to distribute the heat, the temperature gradient is unimaginably steep. The boundary between molten day and frozen night would be a razor's edge of tectonic catastrophe, a permanent storm of shattering rock and solidifying lava. Kepler 10b stands as a foundational archetype of cosmic extremity, a reminder that the most basic force in the universe, simple proximity to a star, can forge a landscape of absolute geological violence. It redefines the very idea of a rocky planet, proving they can form and survive in places we once thought were only for gas giants. If this is where our journey starts, with a world of simple, brutal incineration, what does it say about the destination still to come? If Kepler 10b is a world defined by fire, its neighbor in cosmic extremity is defined by the unimaginable pressure that fire creates. 55 Cancri E is a super-Earth, a rocky world with nearly twice the diameter of our own, but any similarity ends there. It orbits its sun-like star in a mere 18 hours, a year that passes in less than a single Earth day. This proximity creates a surface temperature hot enough to melt stainless steel, a landscape perpetually glowing with infernal heat. Yet the true nature of this world is hidden beneath that blazing surface. Astronomers believe its composition is extraordinarily rich in carbon, the same element that forms the graphite in a pencil and, under the right conditions, the most coveted gemstone on Earth. Here, the conditions are not right, they are monstrous. The planet's immense mass and the gravitational forces within its interior create pressures millions of times greater than what we experience at sea level. In this environment, carbon atoms are not given a choice. They are forced into the rigid, crystalline structure of diamond. The core of this world may not be molten iron, but a vast, seething mass of crystallized carbon, a diamond of planetary scale. It is a trove of cosmic treasure buried under a sky that is itself a form of hell. Observations suggest the atmosphere, if it still clings to this scorched rock, could be composed of poisonous gases like carbon monoxide or cyanide, a toxic shroud over a gemstone core. This presents a profound and ironic twist, a world of literally incalculable material wealth, existing in a place where the very concept of value loses all meaning. The diamond is not a rare jewel here, it is the bedrock, forged not by gentle geological processes but by the brutal, relentless forces of gravity and heat. 55 Cancri E stands as a monument to cosmic alchemy, where the ordinary stuff of the universe is transformed into the extraordinary under the most extreme conditions imaginable. It forces us to ask, if beauty can be born from such crushing pressure, what other impossible wonders might be waiting in the dark? But a world of solid diamond is at least stable in its torment. HD 209-458b, a gas giant nicknamed Osiris, presents a different kind of hell, one of slow, spectacular dissolution. This is a hot Jupiter, a planet as massive as our own Jupiter, but orbiting its star in a staggeringly close 3.5 days. The stellar radiation it endures is over 1,000 times more intense than what Earth receives, and this energy is literally cooking the planet away. We are not watching a static, scorched world. We are witnessing a cosmic execution in progress. The upper atmosphere of Osiris is superheated to over 18,000 degrees Fahrenheit, causing the hydrogen gas that forms its bulk to expand violently and escape the planet's gravity. This creates a vast, comet-like tail of gas streaming behind the planet for millions of miles, a ghostly banner of its own destruction. Telescopes have directly detected this evaporation, measuring the distinct signature of hydrogen and even heavier elements like oxygen and carbon being blasted into the void. The process is relentless, a planetary sandstorm where the grains are entire molecules, stripped away by the hurricane-force stellar wind. Scientists estimate Osiris is losing over 10,000 tons of its mass every second. While its total bulk is so immense this demolition will take billions of years, the outcome is already written. This is a dynamic, violent hell, a world in the process of cosmic demolition. It shows us that planetary destruction is not always a cataclysm of impact or explosion, but can be a slow, relentless erosion under an unforgiving sun. The very forces that give light and life can also, with a different alignment, enact a sentence of gradual erasure. If a gas giant can be dismantled atom by atom, what does that suggest about the fragility of smaller, rocky worlds caught in similar stellar furnaces? While some worlds blaze with the fury of their sun, the next destination on our tour is defined by an absence so profound it becomes its own form of terror. TESS is the darkest exoplanet ever discovered, a gas giant that reflects less than 1% of the light that strikes it. To put that in perspective, black acrylic paint reflects about 10 times more light than this planet's atmosphere. Orbiting its star at a distance of only 3 million miles, its surface temperature is a scorching 1,800 degrees Fahrenheit, hotter than molten lava. This creates a staggering paradox, a world of searing, invisible heat shrouded in perpetual, abyssal night. If you could stand on a platform in its upper atmosphere, you would see nothing but an endless, featureless black in every direction, a darkness so complete it feels like a physical substance. Yet your skin would blister instantly from the intense, ambient thermal radiation, a heat you cannot see, only feel as it cooks the air around you. Scientists believe this impossible blackness comes from a poisonous atmospheric brew. The searing temperatures may prevent the formation of reflective clouds like the ammonia bands we see on Jupiter. Instead, the atmosphere could be saturated with light-absorbing chemicals, gaseous forms of sodium and potassium, or perhaps titanium oxide, a compound used in sunblock on Earth but here acting as a cosmic light trap. This world is a cosmic paradox, a place where the very concept of sight loses meaning. It challenges our assumption that heat and light are inseparable companions, presenting instead a vision of hell as an endless, hot void, a place where light itself is swallowed whole. If darkness can be this absolute and this hot, what other sensory inversions might be waiting in the depths of space? The paradox of TESS is a darkness that burns. But what if the opposite were true, a world so violently illuminated by its own weather that it glows from within? WASP 76b offers a spectacle of atmospheric alchemy that redefines the very meaning of rain. This ultra-hot Jupiter, a gas giant orbiting perilously close to its star, is tidally locked, presenting one face to a perpetual, scorching day and the other to an endless, cooler night. The temperature difference between these two hemispheres is not merely a statistic, it is the engine for a meteorological nightmare. On the day side, temperatures climb beyond 4,000 degrees Fahrenheit, a heat so intense it does more than melt rock, it vaporizes metals. Elements like iron, which on Earth form the solid core of our planet, are boiled directly into a gaseous state, becoming part of a superheated metallic atmosphere. This is where the true spectacle begins. Fierce, supersonic winds born from the colossal energy imbalance race from the day side toward the night side. They carry with them this vaporized iron, a shimmering, poisonous fog. As this metallic air crosses the boundary into eternal darkness, the temperature plummets by over 1,000 degrees. In the sudden chill, the iron can no longer remain a gas. It condenses, forming droplets not of water but of molten metal, and then it falls. On the night side of WASP 76b, it rains liquid iron. Imagine standing in that perpetual twilight zone, the Terminator line where day meets night, looking up into a black sky streaked with the faint, glowing trails of descending metal. The ground, if there is any solid surface deep below, would be paved with a slowly cooling crust of iron. This is not speculation. Astronomers using powerful instruments like the espresso spectrograph have detected the clear chemical signature of iron vapor on the hot day side, and its conspicuous absence on the cold night side, the very evidence needed to confirm this incredible cycle. It is a weather system born from stellar fury, a permanent global storm where the precipitation is literal poison, and the clouds are made of element forged in the hearts of dying stars. This world transforms a fundamental, life-giving process on our planet into a breathtaking display of cosmic violence, proving that the universe holds wonders far stranger than any myth of rivers of fire. A world of iron rain is a monument to stellar violence made tangible, but some infernos are not defined by what they create, only by what they destroy. HAT P32b is a cosmic ghost, a planet in the process of vanishing before our eyes. Classified as a Puffy planet, this gas giant presents a staggering contradiction. It is nearly twice the size of Jupiter, yet contains only about half the mass. This makes it less dense than a cork, a bloated, tenuous sphere of gas held together by the faintest gravitational whisper. The reason for this impossible inflation is the relentless stellar radiation from its parent star, which orbits so close it completes a year in just over 2 Earth days. Imagine holding a marshmallow over a blowtorch, watching it swell and bubble as the intense heat causes its internal structure to expand. HAT P32b is that marshmallow on a planetary scale, its atmosphere superheated from the outside in, causing it to puff out into a distended, low-density shroud. This is not a stable state. The planet's outer layers are so weakly bound that astronomers detect a vast, comet-like envelope of hydrogen gas streaming away into space, an atmospheric hemorrhage on a cosmic level. The core within, whatever rocky or metallic heart it may have, is likely a compressed, collapsing relic, shrouded by an atmosphere that is actively evaporating. This world represents a different kind of extremity, one of profound instability and dissolution. It is a hell not of pressure or solidity, but of unsustainable expansion, a glimpse into the volatile end stages of a planet's life under an unforgiving sun. While a diamond world is forged by crushing pressure, HAT P32b is being unmade by relentless heat, its very substance scattering into the void. If a world can be so fragile, so ephemeral, what does that tell us about the delicate balance that allows a planet like our own to endure? While some worlds suffer under a constant, unyielding sun, the torment of HD 80606b is defined by a brutal and predictable rhythm. This gas giant does not orbit in a placid circle. It follows a wildly stretched ellipse, a cosmic roller coaster that subjects it to the most violent seasonal shifts imaginable. For most of its 111-day year, it swings far out into the cold depths of its system, a frigid and lonely wanderer. But then, in a matter of just hours, its orbit whips it perilously close to its star, a close approach called perihelion. During this dramatic plunge, the amount of stellar radiation bombarding the planet increases by a factor of nearly 1,000. The surface temperature doesn't just rise, it explodes, soaring over 1,000 degrees Fahrenheit in less than a single Earth day. This isn't a gradual summer, it's the atmospheric equivalent of thrusting an ice cube directly into a blast furnace. The physics of such an event are catastrophic. This sudden, immense heating doesn't just warm the air, it creates a thermal shockwave of staggering power. The atmosphere on the star-facing side superheats and expands at a supersonic rate, generating winds that could eclipse the fiercest hurricanes we know, reaching speeds of thousands of miles per hour. These aren't localized storms, they are likely planet-engulfing fury. a global tempest that churns the entire gaseous world into a continuous, chaotic frenzy. Just as quickly as it arrived, the planet then hurtles back out into the frozen dark, and the cycle begins anew. The hell of HD 80606b is not one of constant fire or eternal night, but of relentless scheduled violence. It is a world punished with mechanical regularity by the simple geometry of its own path through space, a lesson in celestial dynamics turned into a brutal, ongoing event. This raises a haunting question about the nature of stability itself. If a world's orbit can be a source of such torment, what other hidden rhythms in the cosmos might dictate fates far stranger than our own? The rhythmic torment of an elliptical orbit is a slow, predictable countdown, but for WASP 18b, the clock is not just ticking, it is winding down at an alarming rate. This isn't a world with a harsh climate, it is a planet with an expiration date. A gas giant nearly 10 times the mass of Jupiter, it orbits its star in less than one Earth day, a proximity so intimate that the star's gravity is actively dragging it inward. With every single orbit, WASP 18b loses a little more energy, spiraling closer to its own destruction. Astronomers calculate its orbit is decaying so rapidly that it could collide with its star in a mere 1 million years, a blink in cosmic time. This is a memento mori written in the laws of celestial mechanics, a world living under a death sentence pronounced by gravity itself. Yet its present condition is its own form of hell, a preview of the inferno to come. Spectroscopic analysis has revealed an atmosphere utterly alien to our own. It is dominated not by water vapor or hydrogen, but by carbon monoxide. This odorless, poisonous gas, lethal to humans in tiny concentrations, forms the bulk of this world's sky. The atmosphere is also devoid of water vapor, suggesting a scorching, dry environment where the chemistry for life as we know it is not just absent but impossible. The immense pressure from the planet's gravity compresses this toxic shroud into a suffocating, superheated oven, a place where the very air is a uniform, deadly poison. This presents a profound duality of extremity. WASP 18b suffers both a toxic, crushing existence in the present and carries the certainty of a cataclysmic future. It forces us to confront a planet's mortality not as a distant philosophical concept, but as a measurable, ongoing process. We are witnessing the final chapters of a world's life, a slow-motion plunge into a stellar furnace. If a planet this massive can be so utterly doomed by its own star, what does that imply for the long-term stability of any world, including our own, in the grand and unforgiving clockwork of the universe? The finality of a doomed orbit is a specific kind of cosmic sentence. But what if the star itself has already undergone a death and rebirth, dragging its planets through an apocalypse and into a new, even more ferocious existence? The story of Kepler 70b and C is not one of a stable system, but of a cataclysm survived, only to find oneself in a deeper circle of hell. Their sun is not a main sequence star like our own, but a B-type subdwarf, the incredibly hot, dense core left behind after a star shed its outer layers in a red giant phase. This stellar remnant is a furious ember blazing with ultraviolet light, and around this cinder, two worlds complete their orbits in a matter of hours. Kepler 70b, the innermost, has a year of just 5.7 hours. The surface temperatures on these planets are not merely hot, they are stellar, estimated to exceed 10,000 degrees Fahrenheit, hotter than the surface of some red dwarf stars. This heat is so intense it breaks the very definition of a planetary environment. These are not worlds with surfaces as we understand them. They are most likely the naked, scorched cores of what were once gas giants. Their vast atmospheres boiled and blasted away during the star's violent transformation. Now they orbit so close that they plow through the star's own extended outer atmosphere, a region of tenuous but searing plasma. The line between planet and star here is not just blurred, it is actively being erased. This is a hell of pure, unmediated stellar fury, a realm where the concept of a solid world dissolves into a haze of incandescent vapor and elemental soup. They are cosmic phantoms, the ghosts of planets that lived through one inferno only to be condemned to another, far more intimate one. Their existence challenges our categories, asking what remains of a world after its sun has died and been reborn in a more violent form. After a star's death and rebirth, we might expect only barren cinders, but the cosmos specializes in unexpected chemistry, forging substances that should not exist under the very laws that create them. GJ436b, a world known as the Burning Ice Planet, is a masterpiece of cosmic contradiction. It belongs to a rare class called hot Neptunes, worlds with masses similar to our solar system's blue ice giants but orbiting perilously close to their stars. This particular planet completes a full orbit in just over 2 Earth days, with surface temperatures soaring to around 800 degrees Fahrenheit, hot enough to melt lead. Under that blistering hydrogen-rich sky, however, lies a profound mystery. The immense gravitational pressure from the planet's mass, estimated to be over 20 times that of Earth, creates conditions deep within its interior that defy our everyday experience. Here, water is not a liquid or a vapor. Scientists believe the crushing force could compress water molecules into an exotic, crystalline solid form known as supersonic ice or hot ice. Imagine a substance with the rigid lattice structure of an ice cube, but existing at a temperature where water should be a raging, superheated steam. This is not science fiction. It is a predicted state of matter where oxygen atoms are locked in a solid crystal while hydrogen ions flow through it like a liquid metal, creating a highly conductive and bizarre layer. This means the planet could literally have a mantle of solid, burning ice beneath its searing atmosphere. The strangeness does not stop there. Observations suggest the upper atmosphere is rich in carbon. Some models propose that this carbon could condense into droplets of methane that fall as rain, or even coalesce into tiny particles akin to soot, creating a hazy hydrocarbon shroud over the entire world. GJ436b is a hell defined not by simple fire, but by the alchemy of extreme pressure. It takes the most fundamental ingredients for life, water and carbon, and subjects them to a laboratory of such ferocity that they transform into forms we can barely comprehend. This world is a direct challenge to our categories, proving that the universe is not just more imaginative than we are. It is capable of bending the very rules of chemistry into shapes that seem to us like pure paradox. If water can be a hot solid and methane can fall as rain in a furnace, what other impossible states of matter are waiting to be discovered on worlds we have yet to find? The paradox of burning ice is a marvel of pressure's hidden alchemy, but some hellscapes are defined by a far more direct and brutal form of transformation. K2141b is a rocky super-Earth that has turned its entire surface into a perpetual, self-consuming furnace. Tidally locked to its star, its dayside is a single, unbroken ocean of lava, estimated to be over 60 miles deep. Temperatures here soar beyond 5,000 degrees Fahrenheit, a heat so profound it doesn't just melt rock, it vaporizes it. The very bedrock of this world, the silicates and minerals that form its crust, are boiled directly into the sky, creating a thin, toxic atmosphere composed of rock vapor. Imagine a wind not of air but of vaporized stone, a shimmering, poisonous fog rising from a sea of fire. This is where the planet's horrific weather cycle begins. The immense temperature difference between the incandescent dayside and the freezing, permanent night drives supersonic winds that scream across the Terminator line at over 3,000 miles per hour. These gales carry the mineral-laden vapor into the eternal darkness. On the night side, temperatures plummet to hundreds of degrees below zero. In that sudden, profound cold, the rock vapor cannot remain a gas. It condenses. First, it forms tiny particles, a kind of rocky snow that drifts down from the black sky. Further in, the condensation becomes more intense and it begins to rain. But these are not droplets of water, they are droplets of liquid rock, a downpour of molten mineral that falls onto a frozen, solid surface. The precipitation then accumulates, building up into glaciers of rock that slowly, inexorably flow back toward the dayside under their own immense weight. Upon reaching the inferno, these stone rivers melt and evaporate once more, completing a global, geochemical cycle of breathtaking violence. K2141b is a world with no solid ground, only a temporary state in an endless loop of evaporation and deposition. It is the ultimate engine of geological horror, a planet that literally eats itself and regurgitates its own substance in a relentless, global storm. This is not a static landscape of fire, but a dynamic, churning machine where the concepts of earth, sky, and weather are fused into a single, terrifying process. The relentless self-consumption of a lava world shows hell as a closed, cyclical machine. But what if the torment comes not from within, but from a sky that is never the same? Kepler 16b offers a different kind of extremity, one defined not by blistering heat, but by profound and perpetual instability. This is the first confirmed exoplanet orbiting not one, but two stars, a real-world counterpart to the fictional Tatooine. While its orbit places it in a frigid region, likely making it an uninhabitable gas giant, its true hell is celestial. Imagine a world where the sun you wake up to is never guaranteed. Some days, a single, small, reddish star dominates the sky. On others, its brighter, larger companion takes the lead, and often, both stars hang together in the heavens, casting a complex, ever-shifting pattern of double shadows that dance and merge across the landscape. The gravitational reality is even more chaotic. The planet does not orbit a single, stable point. It dances a delicate path around the center of mass of both stars as they themselves whirl around each other. This creates a gravitational environment of constant, subtle tugging, a cosmic push and pull that would strain the planet's very structure and wreak havoc on any potential climate. Storms, if they exist in that cold atmosphere, would be driven by forces far more complex and unpredictable than the simple day-night cycle of a single sun world. The psychological weight of such a sky is its own form of torment. There is no constant, no fixed point of light, no reliable rhythm to the heavens. The very cosmos above is in a state of permanent, low-grade frenzy. Kepler 16b represents a hell of confusion and celestial drama, a cold world condemned to an eternal, complicated dance under the twin, watchful eyes of its binary masters. It proves that extreme environments are not always about temperature, but can be about the fundamental disorientation of existing in a universe that refuses to offer a simple, steady dawn. The celestial confusion of a binary star system is a unique kind of cosmic sentence, but to understand the origins of such fates, we must travel back to the very beginning, to a time of raw, unformed chaos. V830 Tauri is a glimpse into that primordial furnace, a gas giant orbiting a star so young it is still in the throes of its own violent birth. This star, a Tauri variable, is an infant by cosmic standards, less than 2 million years old. It is a tempestuous, flaring ball of plasma, lashing out with stellar tantrums that dwarf anything our mature sun could produce. The planet itself is a newborn, likely still accreting material from the disk of gas and dust that birthed it, a world being assembled in real time within a maelstrom. The environment here is one of absolute sterilizing fury. Intense ultraviolet radiation and X-rays flood the system, while colossal stellar flares erupt, bombarding everything in their path with high-energy particles. This is not a place where delicate organic molecules could form or survive. It is a realm where the very building blocks of chemistry are ripped apart as quickly as they assemble. V830 Tauri exists in a state of continuous radioactive bombardment, a world forged not in a gentle cradle but in the heart of a continuous supernova. This is a primordial hell, a snapshot of the violent conditions that may have been the nursery for every gas giant we have discovered. It forces a profound perspective shift. The placid, stable orbits we see in mature solar systems are the calm after a storm of unimaginable violence. The planet we see today, a hot Jupiter orbiting close to its star, may be the scarred veteran of that early epoch, having migrated inward through the chaotic disk. To look at V830 Tauri is to witness the brutal opening chapter in the life story of a world, a reminder that the serene beauty of a night sky is the product of an infancy spent in fire. The primordial chaos of a newborn star system shows how worlds are forged in fire. Yet some planets are not forged, they are unmade, their substance scattered back into the cosmic dust from which they came. KIC 1255754-8b is a ghost in the making, a rocky world caught in the final act of its own evaporation. Orbiting its star in a blistering 15 hours, this small planet endures such intense stellar radiation that its very surface is boiling away. But this is not the graceful atmospheric loss of a gas giant. This is something far more visceral. The heat is so extreme it vaporizes rock, launching a continuous plume of dust and vaporized silicate minerals into space. This cloud of planetary debris is so vast and dense that it creates a distinct, smeared-out signature in the star's light every time the planet transits. Astronomers are not just detecting the planet itself, they are watching its funeral shroud. The process is relentless. Each orbit strips away another layer, scouring the world down to its core. Current estimates suggest this world could be losing the equivalent of an entire Mount Everest worth of mass every million years, a rate of erosion that is utterly geological in its violence. Given its small size, this means it could be completely dismantled within the next 100 million years. This is a hell of ultimate, granular dissolution. There is no cataclysm here, no explosive finale, only the quiet, inexorable scattering of a world into a haze of fine dust. It is a planet turning itself inside out for all the cosmos to see, offering us a morbidly fascinating real-time view of a fate that may await countless other rocky worlds orbiting too close to their suns. As we watch this slow-motion disintegration, we are forced to wonder, is this the silent, dusty end that awaits so many of these infernal worlds, to simply vanish into a glittering mist around a star that showed them no mercy? A dusty, silent evaporation is one way for a world to end, but there are fates far more claustrophobic, where the torment is not dissipation but suffocation. GJ1214b presents a vision of hell defined not by fire but by sheer, smothering weight. Classified as a mini-Neptune, this world is a haunting intermediary, larger than Earth but smaller than the ice giants of our own solar system. Its true nature, however, is veiled by an atmosphere of profound mystery. Observations suggest a thick, global shroud, likely a deep and steamy envelope of hydrogen and helium, but one so dense with water vapor and other compounds that it acts as a permanent, global fog bank of cosmic proportions. This is not a transparent sky you can see through. It is an impenetrable, crushing blanket that stretches from the void of space all the way down to what? That is the central question. The atmospheric pressure at the base of this global ocean of gas would be hundreds of times greater than anything at the bottom of our deepest seas. Under such fantastic force, the very physics of familiar substances breaks down. Scientists theorize that the conditions could create exotic, alien states of matter. Water, for instance, might not exist as a liquid or a vapor. It could be compressed into a form called supersonic ice, a hot, crystalline solid where oxygen atoms are locked in a lattice while hydrogen ions flow through it like a liquid metal. Or it might become a superfluid, a substance with zero viscosity that defies our understanding of friction and flow. The surface of this world, if we can even call it that, is not a solid crust of rock. It is buried under hundreds of miles of this pressurized fluid, a gradual transition from thick atmosphere to a global, slushy ocean that eventually gives way to a mantle of hot, high-pressure ices and perhaps a small, rocky core. GJ1214b is a hell of profound opacity and pressure. There is no vista here, no horizon, only an endless, featureless gradient from tenuous haze to crushing fluid. It represents a universe where the sky itself becomes an ocean, and the very ground is a concept lost to unimaginable depth. This world forces us to abandon our need for a solid foundation, asking what it means to be a planet when the line between atmosphere and surface dissolves into a single, suffocating embrace. A world can rebel against the very system that gave it birth. WASP 17b is a cosmic heretic, a gas giant that defies one of the most fundamental rules of planetary formation. It orbits its star backwards, while nearly every planet in our solar system spins and orbits in the same general direction as the Sun's rotation. This world moves in a retrograde path, circling opposite to its star's spin. This is not a minor quirk, it is a flagrant violation of the natural order, a clear sign of a profoundly violent history. The planet itself is a study in extremes, a puffy giant inflated to nearly twice the size of Jupiter, yet containing only half the mass, giving it a density less than that of styrofoam. This bizarre combination, a bloated, backwards world, points to a cataclysmic origin story. Astronomers believe WASP 17b was likely born in a normal, orderly orbit far from its star. But in the system's chaotic youth, a gravitational encounter with another massive object, perhaps a sibling planet or a passing star, violently threw it off course. This gravitational slingshot could have sent it careening inward on a wildly tilted and reversed path, while the intense stellar radiation it now endures puffed its atmosphere into its current distended, ghostly form. The hell of this world is not found in simple heat, though it is scorching, but in its state of permanent astrophysical dissonance. Existing in this misaligned orbit subjects the planet to complex, twisting tidal forces from its star, stirring its superheated atmosphere into a continuous, chaotic churn. It is a world born from an act of cosmic violence, and it continues to live in the echoing aftermath of that rebellion, a permanent testament to the chaos that can lurk within even a seemingly stable system. If a planet's very path can be so brutally inverted, what other hidden scars of ancient celestial battles might we find etched into the orbits of distant worlds? While some worlds rebel against their stars, others are locked in a frantic, inescapable embrace. Epic 228813918b experiences time itself at a dizzying alien scale. Its entire year, one full orbit around its dim red dwarf star, lasts a mere 4.3 hours. In the time it takes for a single Earth day to pass, this rocky world completes nearly 6 full revolutions, living through thousands of its own years in the span of a human lifetime. This relentless tempo creates a hell defined by perpetual motion and ceaseless bombardment. The planet orbits so close that its star, a cool and faint red dwarf, still fills a substantial portion of the black sky, a sullen, crimson eye fixed in place due to tidal locking. But the true terror comes from the star's temperament. Red dwarfs are notorious for their violent flares, sudden eruptions that unleash torrents of X-rays and ultraviolet radiation. At this intimate distance, the planet has no defense. Its surface and any potential atmosphere is continuously scoured by these stellar tantrums. This is not a place of weather or geology as we know them. It is a sterile, irradiated wasteland, The high-energy radiation acts like a cosmic sandblaster, breaking apart any complex molecules that might dare to form. The very chemical foundations for anything resembling life are shredded as quickly as they assemble, leaving behind only a barren, scorched rock under a perpetual storm of invisible, lethal light. The planet's existence is a frantic dance on the edge of oblivion, each fleeting 4-hour year a single step in a ballet choreographed by gravity and stellar fury. It presents a profound contrast to the vast, slow geological ages of our own world, forcing us to consider that time and the events that fill it can be compressed into a frantic, desperate rhythm utterly alien to our own experience. The frantic rhythm of a world with a 4-hour year shows time compressed to a point of frenzy. But what if a planet's torment is not measured in speed, but in a single, unblinking eye of perpetual fury? Kepler 7b offers a different vision, a climate frozen in a state of permanent, organized violence. This is a world where the weather map does not change with the seasons because there is only one feature to map, a single, colossal storm. While hot Jupiters are often chaotic maelstroms, Kepler 7b presented astronomers with a startling discovery, the first ever cloud map of an exoplanet. Using data from the Kepler and Spitzer space telescopes, scientists didn't just detect this distant gas giant, they painted a portrait of its atmosphere. What they found was not a uniform shroud but a stark asymmetry. One hemisphere of the planet is dominated by a brilliant, reflective cloud, likely composed of silicates or metallic vapors condensing high in the atmosphere. The other side is comparatively clear and dark. This stark divide is not a temporary condition. It is locked in place, a permanent feature sculpted by the planet's eternal, tidally locked gaze toward its star. The clear side faces the stellar furnace, its heat absorbed by deeper, hotter atmospheric layers. The cloudy side, in permanent twilight, acts as a colossal storm system of staggering stability. Think of Jupiter's Great Red Spot, a hurricane that has raged for centuries but scaled that up to a planetary level. This is not a storm that passes, it is the environment. Winds at its boundaries likely scream at thousands of miles per hour, not in a chaotic gale, but as part of a vast, smooth, and horrifically efficient engine of atmospheric circulation. The hell of Kepler 7b is one of meteorological monotony, a climate stripped of all variation and distilled into a single, eternal expression of tempest. There is no calm before this storm because the calm never comes. There is only the storm itself, a monument to atmospheric dynamics pushed to a stable and terrifying extreme. It asks a haunting question about the nature of weather itself. Can a permanent state of fury ever become, for a world, a kind of perverse and silent peace? Even a permanent storm offers a kind of predictable, if violent, equilibrium. But what if the very ground beneath your feet or the sky above was never guaranteed to remain the same from one millennium to the next? Kepler 453b presents a vision of cosmic paradise twisted into a subtle, long-term torment. This world holds a rare and tantalizing position. It orbits within the habitable zone of not one, but two stars, a true Tatooine-like binary system where a distant sun could theoretically allow liquid water to exist. Yet here, the promise of the habitable zone is a cosmic mirage. Kepler 453b is not a rocky world like Earth. It is a gas giant, likely with no solid surface to speak of, a vast, gassy sphere utterly inhospitable to life as we know it. The true hell, however, lies not in its composition but in its destiny. The gravitational dance between the two stars creates a complex and unstable environment. Over long timescales measured in tens or hundreds of thousands of years, the subtle, persistent tugs from each star are predicted to warp the planet's orbit. It will not circle peacefully forever. Instead, its path will slowly oscillate, shifting its distance from the stellar duo in a long, slow, and inexorable cycle. Imagine a world where the climate is not ruled by seasons, but by celestial mechanics on a grand and patient scale. As the orbit shifts, the amount of energy the planet receives would change dramatically. Wild climatic swings would be inevitable, not as weather but as global climatic eras. The planet's atmosphere, already a churning mix of hydrogen and helium, could be subjected to periods of intense heating and expansion, followed by epochs of deep cooling and contraction, all driven by the silent, gravitational negotiation happening overhead. This is a hell of profound instability and false hope. It exists in the Goldilocks zone, a place of cosmic potential, yet it is itself a monument to that potential being forever out of reach. Its beauty is its treachery, a reminder that a stable orbit is not a given, but a precious and fragile gift. The planet is engaged in a beautiful but treacherous balancing act, a performance where a single misstep, dictated by mathematics, could eventually send it spiraling into a new and unknown fate. The eternal storm of Kepler 7b shows a climate frozen in time, but on some worlds, the weather itself is composed of substances we would never think to call rain. Kepler 13b is an ultra-hot Jupiter where the sky is not made of air, but of vaporized metal. Orbiting so close to its star that its dayside temperature exceeds a staggering 5,000 degrees Fahrenheit, this world is a crucible for alien chemistry. Under that stellar glare, compounds that on Earth are solid minerals are boiled directly into a gaseous state. One of the most prominent is titanium oxide, the very substance we use in white paint and high-performance sunblock. Here, it does not block the light, it becomes the atmosphere. On the scorching day side, titanium oxide exists not as a cloud or a dust, but as a shimmering metallic vapor, a constituent of a superheated sky. This is where the planet's bizarre meteorological cycle begins. Fierce, supersonic winds, generated by the extreme temperature difference between day and night, sweep this gaseous metal toward the eternal darkness of the night side. As the vapor crosses into the cold, something extraordinary happens. The temperature plummets by thousands of degrees, and the titanium oxide can no longer remain a gas. It condenses not into a liquid but directly into solid particles. These microscopic flakes then begin to fall. On the night side of Kepler 13b, it snows titanium oxide. Picture standing in that perpetual twilight, looking up into a black sky glittering with the faint, descending specks of metallic snow. The ground, if any solid surface exists that deep in the atmosphere, would be coated in a strange, glittering frost of sunblock and paint pigment. This is a hell defined not by simple heat or pressure, but by the complete subversion of familiar materials. It takes a compound we associate with protection and decoration and transforms it into the engine of an alien weather system, proving that the building blocks of our everyday world can become the stuff of cosmic nightmares under the right, or rather the terribly wrong, conditions. A world of metallic snow is a slow, stately transformation. GJ3470b is a world in a state of emergency, its atmosphere hemorrhaging into space at a rate so frantic it defies comparison. While other planets lose their skies over billions of years, this low-mass mini-Neptune is being stripped 100 times faster than its infamous cousin, GJ436b. The process is not a gentle evaporation but a violent, ongoing dismantling. This planet is caught in a dramatic metamorphosis, a live demonstration of cosmic surgery without anesthetic. Its star, a quiet red dwarf, may seem less ferocious than the brilliant suns that scorch hot Jupiters, but its proximity is the true weapon. Orbiting incredibly close, the planet's puffy hydrogen-helium envelope is superheated and stretched thin, making it tragically vulnerable to the star's gravitational pull and relentless particle wind. With each orbit, vast plumes of gas are ripped free, streaming behind the planet in a visible tail of its own dissolution. Astronomers can actually measure this loss by watching the distinctive signature of hydrogen in the star's light as the planet transits, a spectral fingerprint of a world coming undone. The implications are staggering. GJ3470b is likely in a transitional state, a bloated gas world on its way to becoming something else entirely. As its fluffy atmosphere is torn away, the dense, rocky core within is being gradually exposed to the void. We may be witnessing the birth of a future super-Earth, a world forged not by accretion but by stellar stripping. This is a hell of rapid, brutal exposure, a planet having its protective blanket ripped off and its naked heart left to face the cosmos. It forces a profound question about planetary identity. When a world loses its sky, what is it that truly remains? HD20782b is a prisoner of its own path, a world condemned to an endless cycle of climatic whiplash. This gas giant holds a grim distinction. It possesses the most stretched, elliptical orbit ever measured for a planet of its kind. Its journey is not a gentle circle, but a lopsided oval of staggering proportions. For the vast majority of its 597-day year, it is a lonely exile, drifting in the frigid outer darkness of its system, a frozen wanderer far from its star's warmth. Then comes the plunge. Drawn by gravity, it accelerates inward on a trajectory that feels less like an orbit and more like a kamikaze dive. It screams past its star in a blisteringly close approach, a stellar brush with fire that lasts only a fleeting moment before the momentum of its orbit slingshots it back out into the deep freeze. This is not a seasonal change, it is a full-scale atmospheric apocalypse on a regular schedule. The physics are brutal. As the planet swings into that close pass, the stellar radiation flooding its atmosphere increases by a factor of over 100 in a matter of weeks. The upper layers of its gaseous body don't just warm, they erupt. The sudden, immense heating triggers shockwaves in the atmosphere, likely generating planet-wide tempests of unimaginable fury. Hurricane-force winds, perhaps thousands of miles per hour, would churn the entire world into a continuous, chaotic frenzy, redistributing the explosive heat. Then, just as quickly it flees, the atmosphere, superheated and expanded, now faces the opposite extreme, a rapid and profound cooling as it retreats back into the void. This constant, rhythmic expansion and contraction would stress the very fabric of the planet's gaseous envelope, creating a permanent state of global seismic unrest in its sky. HD20782b experiences hell as a predictable, inescapable rhythm. It is a world living by a celestial metronome set to a beat of freeze, furnace, and storm. This endless roller coaster forces us to see a planet's climate not as a stable condition, but as a temporary state dictated by a simple, unyielding geometry written in the sky. The rhythmic climatic whiplash of an elliptical orbit is a torment of predictable extremes, but on TOI 1431b, the heat reaches a level so absolute it annihilates the very concept of chemistry itself. This ultra-hot Jupiter, also known as Mascara 5b, endures dayside temperatures that may soar beyond 4,000 degrees Fahrenheit, ranking it among the most scorching worlds ever catalogued. This is not merely a furnace, it is a realm of elemental dissolution. At such staggering thermal energy, the bonds that hold molecules together are shattered by the relentless stellar radiation. In its upper atmosphere, there is no water vapor, no carbon monoxide, no methane. These familiar compounds cannot exist. Instead, the sky is a seething soup of individual atoms, a plasma-like state where oxygen, carbon, titanium, and iron float freely in a dissociated haze. This is a world where the rules of chemistry are not just bent, they are suspended entirely. The environment is so violent that atoms are stripped of their electrons, creating a thin, scorching plasma agitated by the star's relentless glare. It represents a fundamental upper limit, a borderland between a planetary atmosphere and the outer layers of a star. On TOI 1431b, matter is reduced to its most basic building blocks, a chaotic primordial soup simmering under an unforgiving sun. It forces us to confront a simple, staggering truth. There exists a temperature where the idea of weather, of climate, even of an atmosphere as a coherent mixture of gases, ceases to have meaning. This is not a world with a toxic sky, but a sky that is toxic by its very atomic nature, a place where the universe demonstrates the raw, disassembled state from which all complexity arises and into which it can so easily return. The universe has shown us skies that rain iron and worlds of hot diamond, but this kind of alchemy is not exclusive to distant stars. To understand the true scale of these extremes, we sometimes need to look closer to home, into the deep, blue heart of our own solar system. Neptune, the ice giant at the edge of our planetary family, is not an exoplanet, but it provides an essential baseline, a glimpse into a process that connects the familiar to the utterly alien. This distant, frigid world, with its supersonic winds and mysterious internal heat, hides a secret within its slushy mantle. The pressures deep inside Neptune are millions of times greater than anything on Earth's surface, creating an environment where familiar substances undergo radical transformations. Here, scientists believe the abundant carbon, freed from molecules like methane, is subjected to such immense force that its atomic structure is forcibly rearranged. The carbon atoms are squeezed into the rigid, crystalline lattice of diamond. But this diamond is not a static gemstone buried in the core. In the dense, fluid interior, these diamond crystals form and then begin to fall. They sink through layers of exotic, high-pressure ices and slush, descending in a slow, glittering hail toward the planet's heart. This is a diamond rain, a beautiful and violent meteorological event happening not in the sky, but deep within the body of a world. This phenomenon is believed to be a common feature of ice giants, a fundamental part of their internal dynamics. It shows us that the line between the ordinary and the extreme is remarkably thin. The processes we label as hellish on distant exoplanets are not mere cosmic anomalies. They are part of a broad and continuous spectrum of planetary behavior. Neptune's inner diamond rain is a form of internal high-pressure hell, a reminder that even in our own celestial backyard, nature operates with a ferocity and creativity that rivals anything found light years away. It sets a critical stage, transforming these distant exoplanet horrors from pure fantasy into a logical, if breathtaking, extension of the physics we already know. If this serene, blue orb can harbor such a storm of crystallized carbon within, what does that imply about the more intense, more exposed versions of this process waiting on worlds that orbit far closer to their sun? Neptune's inner diamond rain shows that even familiar worlds can harbor hidden, violent alchemy. But there exists a final, ultimate category of world that makes even the most extreme orbit seem like a stable home. Our 25th destination is not a single exoplanet, but a theoretical abyss, a class of world defined by Exile. These are rogue planets, celestial orphans violently ejected from their birth star systems during gravitational upheavals in their youth. Cast adrift, they wander the interstellar void in perpetual, perfect darkness. Their hell is not one of fire, but of frozen, silent eternity. Without a star to warm them, their surface temperatures plummet toward absolute zero, the coldest possible temperature in the universe. Any residual internal heat from their formation, any lingering warmth in a possible molten core, slowly bleeds away into the infinite blackness of space over billions of years. The process is irreversible. Atmospheres, if they ever had them, would freeze solid and collapse, coating the surface in layers of nitrogen or oxygen ice. Tectonic activity grinds to a halt. The world becomes a dead, frozen globe, a geological tomb drifting forever between the stars. This is the antithesis of every fiery hell we have explored, a chilling counterpoint of absolute isolation. Where scorching worlds are defined by the violent embrace of their star, rogue planets are defined by the total absence of one. They represent the ultimate cosmic loneliness, a fate of endless, quiet drifting in a sea of nothing. It forces a profound final reflection. Our tour began with worlds boiling under too much attention from their suns. It ends with a vision of what happens when that attention is removed completely, when a world is utterly and forever forgotten by the light. In the grand narrative of the cosmos between the inferno and the absolute zero, we find the full, terrifying spectrum of what it means to be a planet. These 25 worlds are not a gallery of cosmic mistakes. They are a testament to the staggering creativity of physical law. Each one, from the evaporating rock to the diamond rain, demonstrates the incredible resilience and adaptability of matter itself. Under pressures that crush stone into new crystalline forms, under temperatures that tear molecules apart into atomic soups, the universe is not destroyed. It is simply rearranged into configurations far stranger than our everyday experience can prepare us for. This forces planetary science into a constant state of revision. Our textbooks, built on the quiet, orderly example of our own solar system, must now include chapters on hyper-inflated giants, backwards orbits, and global lava cycles. These hellish exoplanets are the outliers that redefine the center, showing us that our local neighborhood is just one possible arrangement in a vast spectrum of planetary being. This expansion of knowledge carries a profound philosophical weight. For centuries, human thought often placed our experience at the center of the cosmos, imagining worlds that mirrored our own hopes or fears. The silent lesson from these 25 destinations is a humbling corrective. The universe is not designed for our comfort, nor is it obliged to be comprehensible to our senses. It contains entire categories of existence, entire modes of being for matter and energy, that are utterly and irreconcilably hostile to the delicate chemistry we call life. These are not failed Earths, they are triumphant examples of what happens when different rules dominate. A world where it rains iron is not a punishment, it is a perfectly valid, even elegant, solution to the conditions of intense heat and ferocious winds. A planet darker than coal is not an abomination. It is a logical outcome of an atmosphere stripped of reflective clouds and saturated with light-absorbing elements. Therefore, to label these places as hell is to view them through a profoundly human lens. Seen through the dispassionate eye of physics, they are natural outcomes, inevitable products of gravity, chemistry, and stellar evolution playing out on a canvas of unimaginable scale. They are experiments run by nature itself, showing us the outer limits of what is possible. This shifts our perspective from horror to a kind of awe. The true revelation is not that such terrible places exist, but that the universe is capable of generating such breathtaking diversity, from the serene beauty of a frozen rogue planet to the violent majesty of a disintegrating gas giant. In their very extremity, these worlds highlight the astonishing creative potential latent in the cold equations of the cosmos. They ask us not to look away in fear, but to look closer with wonder, for in their impossible fires and crushing depths, we are witnessing the full, untamed spectrum of reality being written in light and stone across the void. From lava oceans and iron rain to diamond crusts and eternal storms, we have charted a cosmos of profound and punishing extremes. These 25 worlds are far more than a catalogue of scientific oddities. They are the definitive benchmarks of physical reality, the hard outer limits of what it means to be a planet. They show us that matter itself is both astonishingly fragile and incredibly resilient, capable of being vaporized, crushed, and scattered, yet always reorganizing into new and breathtaking forms. This journey reveals not a universe of chaos, but one of immense, untamed creativity. Each hellscape is a natural and logical outcome of its specific conditions, a perfect, if terrifying, expression of universal laws. This perspective transforms our understanding. These planets are not failures, they are triumphs of physics, demonstrating the full, spectacular spectrum of possibility that exists when different forces take the lead. As our search continues with new telescopes peering deeper into the galaxy, let these infernal worlds inspire a deeper kind of awe. They are reminders of the boundless scope of nature's imagination, a scope that far exceeds our own. They challenge us to keep looking, to keep questioning, and to remain humbled by the sheer variety of existence waiting in the dark. If this journey into the extreme has expanded your view of the cosmos, subscribe for more explorations into the deepest space mysteries. We would love to hear your thoughts. Which of these exoplanet hellscapes chilled or thrilled you the most? Let us know in the comments below.